So today we're going to learn a new method called completing the square to solve quadratic equations. Quadratic equation just means the degree of the equation is 2. So x squared equals 4 would be a quadratic equation. Now that'd be an easy one. Take the square root of both sides like we talked about the other day. Don't forget plus or minus on one side here. So we get x equals plus or minus 2. You shouldn't be surprised with a quadratic when you get two solutions. Typically with a quadratic, you're going to have two solutions. You got a parabola happening there. And so you may cross, at two places on the x-axis, or sometimes a parabola will cross, like the graph will cross one time. That might have one solution or even no solutions. So typically you're going to have two solutions. Let's try a little harder one. Let's go to this one. X plus 1 quantity squared equals 4. Now this wouldn't be that much harder, but that's kind of what we want. That's our goal in this lesson, to get our equations to look like this, where we have a binomial being squared, and then we just take the square root of both sides. You say x plus 1 equals plus or minus 2. We're almost done. X equals negative 1 plus or minus 2. We have two solutions there for x. X equals negative 1 plus 2, which is 1, or x equals negative 1 minus 2, which is negative 3. And we've got our two solutions. Before we go further in this method, you need to understand and complete the square. We're basing this off this idea of perfect squares. And sometimes when I tell my students what a perfect square is, they go, well, what's a perfect square? Their faces go blank. Well, 1 is a perfect square. 2 times 2 is 4. Or in other words, this is equal to 2 squared. Any kind of number like that. And we know that we've memorized those 1, 4, 9, 16, all the way up to maybe 13 squared, which is 169. But today we're talking about binomials that are being squared. So what if you had something like this? X plus 1 quantity squared. Well, if you look at that as a picture, it's still a square here. We're finding the area. We have to multiply x plus 1, a binomial times a binomial. We have a method for that we usually use. The FOIL method, which distributes here, so we get x squared. We go outside plus inside is 1x plus 1x is 2x. And then last times last is plus 1. So we get this trinomial. This may not look like a perfect square here, but that's a perfect square trinomial. I know that x plus 1's quantity squared is equal to that. And so I want you to start seeing a pattern here. If we did x plus 2 quantity squared, we multiply that out, you get x squared plus 4x plus 4. The pattern may not be obvious with those two, but if you do x plus 3 squared, you start seeing a pattern here. X squared plus 6x plus 9. Same thing with x plus 4 squared. In fact, oftentimes my students can tell me, if I say 8x and I say it's a perfect square, they can tell me what goes there. And maybe some of you see that pattern. If you take half of 6 and square it, you get 9. Half of 8 squared is 16. And if you see that pattern, that's what we're doing. We're taking half of the coefficient of the middle term, squaring it to get that last term. That's called completing the square. That's where this method derives from. In fact, if we used a generic value like a here, and we multiply that out, we get x squared plus 2ax plus a squared. If you take half of this value and square it, you get a squared. That's where this method comes from. So now, the beauty of completing the square is that we can now solve problems like this. X squared minus 8x minus 2 equals 0. So we can't factor that guy. Can't factor it. Well, there's other methods available to us. We want to show off our math skills, so let's use complete the square. We want it to get it kind of look like this. We want x plus a, or minus a negative a there, or minus a there, equals some constant on this side. So we want this to be a constant on the right-hand side. We want it to be a binomial squared on the left-hand side. That's our goal. Once we get there, we can finish solving with no problem. We can do that in our sleep. So the first thing I'm going to do is move this constant over, because that doesn't make a perfect square right there. So I want to make a perfect square, so I'm going to say x squared minus 8x plus blank equals 2. Now notice I put a plus there because The last term of a perfect square, it doesn't matter if this was minus. If this was minus, this would change to a minus, but this would still be a plus here. The last term times the last term will always be positive. So I know I'm going to add something there, and all I do is take half of this number, square it, and put it over there. So half of negative 8 is negative 4. Negative 4 squared is 16. So I'm going to add 16 to both sides to be fair. When you do that, this really will work out nicely. This is the beauty of complete the square. I don't know if you think math is beautiful, but this is beautiful. So I know it's going to be easy to factor because it's going to be the same factor twice. So square root of 16, I don't have to think about it. It's going to be 4 and 4. Same factor twice. Minus 8, so it's going to be minus and minus. Over here we get 18. Take the square root of both. No, you can't take the square root of both sides first. First we have to get this looking a little better. We want it to look like this. So I'm going to write it this way, like a mathematician would write it. X minus 4 squared equals 18. Now I'm ready to take the square root of both sides. Take the square root, don't forget, plus or minus, get x minus 4 equals plus or minus, and this is going to be, if you prime factorize 18, you get 2 and 9, 3 and 3, you got 2 3's and a 2, so we've got a pair of 3's, so I'm going to say 3 root 2 is what that's equal to. Now one last step here. We want to move the 4 over. I always put it in front. It looks better. It'll look cooler to your friends if you do it that way. Look like a mathematician. 4 plus or minus 3 root 2. And there you go. Those are your two answers. That really can't be simplified any more than that because a number, a constant, and a square root don't go together very nicely. They don't play well together. So we're really done with that example. And so complete square is very effective for solving any type of quadratic that's not a perfect square. But we can make it a perfect square and then finish solving. And so that's the beauty of complete the square. We can solve things that factoring can't, we can with complete the square.